Hello all. So today let us continue with the series how to think of a programming logic. So in the last tutorial we have seen what are the steps to write a code, right? So it is understand the problem statement, think of the steps to achieve it, break down each steps again, link everything and write the code. Today let us see another example and let us try to write the code in this manner. So the problem statement is check if a number is prime number or not. Okay, so what's the first step? We have to understand the problem statement, right? So check if a number is a prime number. So what is the first thing that we need to know? What is a prime number? A number is a prime number when it is only divisible by 1 and the number itself, right? So if it is divisible by any other numbers in between, then it is not a prime number. So here, what do we need to check in the code? We need to check if the number is divisible by any other number other than 1 and the number itself, right? So any other number other than 1 and number itself, if the number is divisible by those, then the number is not a prime number. Okay, now what is the input? We need to get a number from the user, and what's the output? We need to print the message whether the number is prime or not. Now how can we achieve this? Okay, so get the number from the user. So what will be the steps? We have to get the number from the user. We have to check if the number is divisible by any number. Then we have to print the results. So these are the steps that we have to achieve, right? Now, how we can break down, we need to break down these steps again, right? So now get the number from user. So as we know, to now we all know how to get the number from user, right? So we have to get the number from the user using input, and then we have to convert it using int, right? So we'll just do that over here. So I'll just simultaneously do the coding part also. So user input equal to, and we need to convert it into a number, right? Because we need to perform the divisibility and everything, we cannot do that with a string, so we need to convert it into a number. So int input enter number. Okay, so we have achieved the first step over here. Now what is the second step? Check if the number is divisible by any number. Okay, so any number. So that is, we have to check for the divisibility from 1 to itself, right? Means if the number is 4, obviously after 4 number 5 and all cannot divide 4, that is for sure. So we have to check whether the numbers between, so suppose the number is 4, so 1 2 3 4. Okay, suppose the number, we have to check for the prime factor, or whether the number is a prime number 4. Okay, 4 is a prime number or not. So obviously 4 is divisible by 4, that we know, and 4 is divisible by 1, that we know. That is not an issue. Okay, so we need to what we need to find is, we need to find the whether these two numbers, that is the numbers between 1 and 4, is able to divide this 4 properly. That is what we need to find. So what we need to do is, we need to generate these two numbers, okay, 2 and 3. Okay, now how we can generate numbers in Python? It is very easy. We have to use a range, right? So we will use a range, and the range can start from 2, right? So it can start from 2, and then the input number here is 4, right? So 4 we need not include, so you just give input number over here, it will take 1 less than that. That is how range works, right? So we need to generate numbers from 2 to till the input number. Then in order to check the divisibility, we have seen that already, you do a modulus or division over there. Modulus division gives you a remainder. So, okay, and if the remainder is 0, means the number is exactly divisible. So that is what we need to do. Then if we have to do repeat this for all these numbers, right? So obviously there is a loop that is involved over there, right? So we'll just write these steps and we will see. So we have the number, Now what we need to do, we need to do a loop. We need to do a loop and generate the number. So we for number in range, we have seen the range starting should be 2 and the ending will be the user input. Okay, so when we do like this, the range will automatically generate these numbers, and for number in this range means, in this sequence mean, in for loop it will take these numbers one by one. Okay, and it will iterate. It means whatever the things are given inside the for loop, inside the for loop, that block will be executed again and again for these set of numbers. So for whatever numbers are present in the sequence, for those set of numbers, this for loop block will be executed. If you are not clear with the for loop, you can see my tutorial on for loop and ranges. It will be very clear. So for number in this range, what we need to do, if this user input, okay, user input over here, percentage number, not percentage, it's modulus operator, double equal to 0. Okay, if it is divisible, then we know that the number is not a prime number, right? So we'll just say number is not a prime number. Okay, so that's what here I have written in the print result part. Print result part, it is given if in the above step, in this above step, whatever we are supposed to do, if it is divisible by any number, we can print it is not a prime number and we can break from the loop. So once we found out that the number is not a prime number, there is no point in going on executing this loop, right? We don't have to do that, right? So we can just break out from this loop. Okay, we can just come out of it. We don't have to execute this loop again and again, right? Mm. But if the entire loop executes without any issue, okay, if the loop is completing without any issue, then we can print it is a prime number. That means then it is not divisible by any of the numbers generated, right? So that is why the entire loop is executing without any issue. In that case, we can print it's a prime number. So how we check whether the entire loop has executed without any issues? We will use the else clause of the loop, right? So that's what we are going to do here. Print number is not a prime number. Now we'll break from the loop. Else, the else part we'll say print number is a prime number. Okay, so I'll just explain the code once again. Here we are taking the user input, converting it into an integer. Now we need to, since we need to check whether the number is divisible by any other numbers other than 1 and the number itself. That's why we are starting with 2 and till the number. Okay, we are generating the sequence of numbers using this range function, and we are using the for loop because we need to iterate through each of the numbers in the sequence, right? So for loop is the best bet over there. Then we'll check if the user input is divisible by any of these numbers. So we'll get the number over here, same variable we are using here. Check if the user input in any of the number. If the remainder is 0, which means that the number is divisible, right? So we print the message number is not a prime number and we break from the loop, because once we find that the number is not a prime number, there is no point in continuing with the loop. Okay, else if the loops execute successfully without any issue, we print the number is a prime number. Okay, so now we will just execute this code and see. Okay, yeah, I enter 4. It's printing number is not a prime number, right? Because 4 is divisible by 2. We know that, right? I am entering 13. It's telling number is a prime number because 13 is not divisible by any other numbers other than 1 and 13. So that is how we wrote this code for the prime number. So first we understood the problem. Until and unless we know what is a prime number, we just cannot write it. So we understood what's a prime number. Then we thought how we can implement it, right? How to check, means if the divisibility and all, how we can check. We just thought of how we can do it, and that too in a programming, from a programming point of view. We thought of that. Then we found out the steps, and then we break those steps again, and then finally we wrote the code. Okay, so that is the approach that you will be following for any kind of question, whether it is simple or complex. Maybe the breaking down part takes a much number of processing over the for a complex problem, but ultimately this is how you will be writing a code. Now, there can always be a confusion whether to use a for loop or a while loop. So as we have seen before, in the for loop, we always iterate over a collection or sequence. Okay. And using the range function, we can generate a sequence. So whenever we have a sequence available, or when we know the number of times loop has to execute, we'll go for a for loop. Got it? So when we know, okay, I have to iterate through this sequence, then obviously it is for loop. Or when we know, okay, I have to iterate it for 100 times starting from 1, okay, from 1 to 100, then okay, obviously I will be using a for loop. Or whenever I know, okay, no, I have to iterate till 1000, but in steps or two, whatever it is, whether we can generate a sequence over there or not. So if we can do that, then obviously we can go for a for loop. Now in case of a while loop, what is a while loop? While loop executes a set of statements as long as the condition is true. So it is based on some condition that while loop is executing. So we use a while loop when we need to check for a condition for loop to work. Okay. So when we don't know exactly how many number of times loop has to execute, and we means whether the loop has to execute or not is dependent on a condition, then we go for a while loop. In that case, we cannot use for loop. In case of for loop, we need to know beforehand what is the sequence through which it is executing. Okay, but in case of while loop, we can go on executing as long as a condition is true. So some intermediate factor can interrupt the while loop. Okay, this is how while loop works. Okay, so whenever we don't know how many times the loop has to execute, or it is loop is executing based on a condition, then we go for a while loop. I hope that is also clear. Now let us take an example of a complex logic. Okay, and here I won't be writing the steps again and again how we'll be doing it. We'll just do the coding along with this. Okay, so now to check if a number is an Armstrong number. Okay, a number, so in order to, so what is a problem statement? We have to check if a number is an Armstrong number. So how do we check whether a number is an Armstrong number? First, we need to know what is an Armstrong number, right? So a number whose sum of each digit powered with the total number of digits is same as the given number. That is, you have a number, okay, and you need then if each of the digits of the number powered by the length of the number. Okay, here the length of the number is 3. That's why each of the digits, okay, 3, 7 and 1, those are the digits in the number, right? All of them is powered by 3. Okay, so 3 raised to the 3, 7 cube, 1 cube. So all these things, and then we add all these things together, then we get a number. If this number is equal to the starting number, then it is an Armstrong number. Got it? So we need what we'll do, we'll take each digits, we power it with the length of the number, we'll do a sum over there, and then the final result should be equal to input number, then it is an Armstrong number. So this is what we have to do. So what are the steps involved here? Obviously we need to get the number, right? So I'll just start the coding along with this. So we need to get the number user input. So as before, I'll do int input enter number. Okay, now find length. Find length of the number and get each digit individually and take its power. Okay, now we have seen many functions and things so far, right? Is it easy to get the length of an integer? No, right? We have not seen how we can get the length of an integer, but we have seen for a string we can easily get the length. Okay, and for a string it is very easy to iterate through each of the characters. That also we have seen. So what we can do is instead of converting it to integer, we'll just keep it as a string. Okay, so logic is always as per your understanding or how easily you can do it. Okay, there is no hard and fast rule that if it is an integer, it has to be converted to integer. If we have to do some integer operations on it, and obviously it has to be converted to integer. But if you feel like, okay, no, if I keep by keeping it as a string itself, I'll be able to better write the logic, then obviously you can go for the string. So it is how you think, how you divide the problem statement, how you understand the problem statement, and how you think you can execute it in the easiest possible manner. Okay, so I have the user input. Now let me find the n, that is to what number we have to find power of. Okay, so n equal to length of user input. Okay, so it's as simple as that. We just got the length now. Now in order to get each numbers in the string, it is very easy. We have seen that earlier. So if you have any doubts in that case, then please go and see my tutorial on strings and its functions. Everything is explained very clearly over there. So 4-digit in user input. Okay, so we get 8 digits from user input. Now what we need to do, we need to find the power of that digit. Okay, so what we can do, power equal to digit raised to n, right? N we have already found over here. So we will found the power it. Then what we have to do, we have to find the sum of these things, right? So in each iteration we will add to a variable sum. So initially the variable sum will be 0. Then with each iteration we find the power and then we go on adding. Okay, that's what we do here. Sum equal to, okay, sum equal to sum plus power. See, if you see, sum is coming in green color, which means that sum is a keyword, so it is not advisable to use that. Okay, so I'll just change it. I'll make it as final sum. Okay, I'll be using, because we cannot, it is not advisable to use a keyword as a variable. So I just changed it. I made it as final sum. Okay, so final sum plus power. So what happens is we take each digits, we find a power of it. Okay, we are finding the power of it. This n we got over here from using the length. Then we are finding the final sum, that is initially the sum will be 0, then first digit you will take. So here what we'll do 0 plus power of dash digit. So that will come in final sum. When the second digit comes, we'll again find the power. Then we'll add that power to the existing sum. Okay. Then it becomes your new sum. So this is how it works. Okay. So we'll find the sum, and then finally once the for loop is over, so I just de-indent it. We have the final sum over there, right? If final sum double, sorry, final sum double equal to the user input. Okay, what we'll do, we'll say print number is an Armstrong number, else print number is not an Armstrong number. Okay, so this is what we will do. So that is the steps that we have listed out over here. We'll get the number, we'll find the length, get each digit individually and take its power, find the sum of these things, and since it has to be done for each digit, we'll go for a for loop over here. Then check if the sum is equal to number and print the result. Now when we execute this, we are going to get an error. I'll just show you that. I executed it. I gave the number same 371. Here we got an error. See, unsupported operand star or power for string. Okay, now here we took the input as string itself, right? We found the length, we are iterating through it as a string. Now here what are we going to do? We are trying to do an integer operation over there with the string, because when you are taking integer characters of a string, it will be a string only, right? Here we are doing an integer operation there using a string. So what we can do is this digit, individual digit, we can convert it using in function. Now let us see 371 number is not an Armstrong number. So again there's a mistake. Why it came as Armstrong number? Our logic is correct. It should have come as number is an Armstrong number. Okay. Now I'll show what is the mistake over here. B. Okay, sorry. Let me just insert a cell over the cell. Yeah. So we got this when we check this thing, final sum and user input, it is not same. Okay. So let us just see. Final sum is 371. Okay. And now user input is 371. Yes, both are 371. What's the difference? Here final sum is an integer and user input is string. We didn't convert it to integer, right? So that's why this comparison operation failed over here and we got number is not an Armstrong number. So what can be done? Here while checking, we'll just convert it into int and then we'll see whether we are getting the correct input. Correct answer. So I gave the input again as 371. Yes, number is an Armstrong number. Oh, I got the answer. Now I'll give some other number 456 and we got the okay 456 and I got it as number is not an Armstrong number. Okay, so this is how you think of the logic of a program. You have to first identify what exactly is the problem, then what are the main steps by which you can execute it, and this each main steps you have to break down into simple steps. Then you have to link everything and write the code. But you will have to practice a lot, and only the practice can make you a perfect programmer. And so just to try, you can just try this thing like find the factorial of a number. The logic is as similar to what we have seen for the prime number. You can just try it and see whether you will be able to find it out. Try it by yourself, then only you will be to learn how to think logically to write a program. That's all for today. Thank you.